Hey guys, so we're going to do 2.3 today, which is using synthetic division to factor polynomials. And this is the best way to do it, especially because it could be any polynomials. We're so used to factoring x squared, but it could be cubed to the fourth, to the fifth, so on and so forth. The best ways to factor is actually to use division. But before we go into synthetic, let's talk about what division actually is from when we were in grammar school, right? So suppose we want to find the zeros of this f of x function. To do this, we would want to solve that it equals 0. But of course, we don't know how to factor this. So one way we can do is if I can tell you that x equals 2 is a 0, that would mean there must be a factor. Okay, so the idea is if I told you ahead of time that x equals 2 is a 0, that means what actually is a factor of this function is x minus 2, okay? So I'm actually going to show you that division right here and prove that it works, okay? So we are going to divide x cubed plus 4x squared minus 5x minus 14 by x minus 2. Okay, if you remember long division, the first thing we do, and I'm going to look at the first term in each spot, what do I multiply x by to get to x cubed? Well, I multiply by x squared, right? Because x times x squared is x cubed. After we figure out how many can go in, then we actually do that multiplication. X times x squared is x cubed. Now I have to do all of it though. Negative 2 times x squared is a negative 2x squared. And this is where the trickiness comes into play with long division. Because after you multiply, remember you need to subtract. So x cubed minus x cubed is 0. But 4 minus negative 2 is 6. And then it's x squared, right? Because when we combine, they don't go away. Okay, and it doesn't change the figure. Now, if you remember, after we subtract, we bring down. So I'm going to bring down that negative 5x. And then we do that all over. How many? What do we multiply x by to get to 6x squared? We multiply by 6x. I can prove that to you because next is multiplication. 6x times x is 6x squared. Now we have to multiply everything. So 6x times negative 2 is negative 12x. After we multiply, we subtract. Makes sense because those cancel, but be careful with your integers here. Negative 5 minus negative 12 is a positive 7, and then we're dealing with x's. We need to bring down that negative 14. Okay, one more time. What do you multiply x by to get to 7x? You multiply by 7. 7 times x is 7x. 7 times negative 2 is negative 14. And what do you know? When you subtract straight down, you get 0. This is how you know it is a factor, because the remainder is 0. There's nothing left over. So what this means is that our original f of x function up here can be factored to x minus 2 times x squared plus 6x plus 7. Okay. Now, as you can see, we could try to factor that and say, what two numbers do you multiply to give you 7 but add to give you 6? Well, there are none. So what happens here is we know that to make this equal 0, x would equal 2. That's easy there. But this one, you would have to do some side work and do the quadratic formula to find that x equals -3 plus or minus the square root of 2. If you need help with the quadratic formula, just come and get me. But the main thing of this is to go through polynomials and learn the quickest way to factor. Okay? So let's go over some definitions right here. Polynomial division. Suppose that d of x and p of x are non-zero polynomials with the degree of p is greater than or equal to the degree of d. Okay? There exists two unique polynomials, q and r, such that p equals d times q plus r, where either r equals 0, the degree of r is strictly less than the degree of d. Well, what does that mean? Okay, p is the dividend, okay? So p has to be a greater degree in polynomial than what we're dividing by, which is our divisor. The quotient is actually our result of that division. And r, the remainder, is of course what is left over. If there's no remainder, then the d is a factor. So like up above, when we put in x minus 2 and did that division, the remainder equals 0. So we know that x minus 2 was a factor of our original polynomial. Okay, the remainder theorem. Suppose p is a polynomial of degree at least 1 and c is a real number. When p of x is divided by x minus c, the remainder is p of c. Okay, so what that means is if we want to find out what the remainder is, all we have to do is evaluate c, or p at c. Okay, now one thing I want you to keep in mind, it's the opposite of what we're putting in. So if we just needed to find the remainder, then we would plug in our c value into our function, and then whatever we came out with is our remainder. Now, suppose p is a polynomial. The real number c is a 0. If and only if x minus c is a factor. Okay, so if we have x minus c, if you plugged in that c, we would get 0. Okay? No remainder if it is a factor. So where does that take us? Well, the easiest way to divide, instead of doing that long division, because there's tons of mistakes you can make with those steps, is synthetic division. So if you have done synthetic division, this will be a reminder. If you haven't, be very, very careful. So what we're going to do is we're going to look back at the long division we did earlier. Okay, the first thing you want to do is put in your function on the right side of this line. Okay, so what we're going to do, instead of putting the whole function, is we're only going to put the coefficients. So we have x cubed, that coefficient's 1, 4x squared, so that's squared right there. We have -5x and -14. Now, one other thing I want to prove to you is this, or point out to you. In the problem we did earlier, we had cubed squared to the first and then a constant. So all the terms were there. If a term is missing, we must put 0 in that place for that coefficient. Okay, we want to keep in mind that we're going x minus c. So remember, we were trying to find out if x minus 2 is a factor, right? See if that goes through. The way synthetic works is, first of all, that coefficient in front of x for that factor needs to be 1, and then we're going to do the C value. So since it's minus C, I'm going to use just the value of 2. So you can either think of it as opposite or think of it as that C value. Okay, what happens with synthetic? That first coefficient is going straight down. So in that case, it's 1. Then what you are going to do is multiply that value by that factor we are trying to test out. So 1 times 2 is 2. Then we're going to put it under the next one. Now, what we do is we add straight down. That's the great thing about synthetic division. We're no longer subtracting and worried about those integers. Now we're adding. So 4 plus 2 is 6. And we're going to repeat those steps. So I'm going to take that 6 and multiply it by that 2, get 12. Add straight down, we get 7. 2 times 7 is 14. And of course, I put 4 there, but it was supposed to be 14. And when I add those two together, I get 0. So that last value will always be the remainder. Now, considering we were using coefficients, how does that relate? Well, if that's the remainder, now that's the constant, that would be x to the first, and that would be x squared. Now remember, this having a remainder 0 tells me that x minus 2 is a factor, okay? And then this is the stuff left over, which in this case is x squared plus 6x plus 7. And wasn't that the answer we got on the other side? Perfect. It's a lot easier using synthetic. So let's try it out down here. We're going to use synthetic division to perform the following polynomial divisions. We're going to find the quotient and the remainder, and then write the dividend, the quotient, and the remainder in the form given in theorem 2.3. Okay. So we're going to do our division. Remember, this means that C is 3. And then we're going to do synthetic. So let me draw that there. And we get 5, -2. Now here, I want to point this out, guys, and I'm going to label it. See, we're missing a term. Does everyone see that? It goes from x squared to the constant. So that means I have to have a 0 here, because I have a 0 x to the first and then a 1. And our C value is 3. All right, I'm going to kind of go through this faster. Remember, the first one comes down. We need to multiply. That gives me 15. We're going to add. That gives us 13. We're going to multiply. That gives us 39. We're going to add. That gives us 39. Multiply again. That gives us 117. We're going to add 118. Okay, let's remember. This is the remainder. So our remainder equals 118. Okay. So knowing that, the theorem allows us to say that we have the factor of x minus 3 times our quotient, which is, don't forget, this would be the constant, x to the first, x squared, 5x squared plus 13x plus 39. And then remember, we add the remainder at the end. So if you go back to the other page, 2.3, this is your D times our Q plus our remainder. Okay. Let's try another one. Okay, be careful. We're missing some things here, right? We're missing a bunch. So let's keep that in mind as we write it down. So in this case, our C is -2. So I'm going to put -2 here. And see, 1x cubed, 0x squared, 0x and then 8. Okay, x cubed, x squared, x, and 8. All right, bring this straight down. 1, multiply, add, multiply, add, multiply, add. The remainder is 0, guys. What does that mean? That means x plus 2 is a factor. Very good. So that means we can state this as x cubed plus 8 can be factored into x plus 2 times, and remember a constant x squared times x squared minus 2x plus 4. We can always check to see if this is factorable. Are there any two numbers that you multiply to give you 4 that add to give you -2? And no, there are not. All right, this is another format. We want to keep in mind that we want the order. We also want to see if we can simplify it because we're dividing by 2x minus 3. So we have to be careful here, okay? So I want to show you a trick. So right here, if you see, I'm going to factor out a 2. So I'm going to simplify, factor out a 2, and I'm going to reorder it so it's in order for me. Okay, so that would be -6x squared minus 4x plus 2. Now I could have factored out a 4, but all I care about is that these 2's are going to cancel. Okay, so I'm going to factor out a 2 here, and I get x minus 3/2. Now, why did I do that? Because that's not factoring out nicely, right? Well, didn't I say when using synthetic division, the coefficient in front of x has to be 1, okay? So these cancel, and I don't have to worry about that. Now I can do the division. C is a positive 3/2. The first coefficient's -6, -4, and 2. Yes, this year you will have to deal with fractions, so we need to get used to using those in our calculator. Okay, so we're going to bring that down to give us -6. -6 times 3/2 is -9. Add those together, we get -13, and this is where it gets sloppy, right? So -13 times 3/2 is -39/2. Now be careful, if you do this on a calculator, remember that fraction needs to be in parentheses. So when you get that, you get -35/2. So now we know that this is not a factor, but we can still write it in that term, right? So we can say x minus 3/2 times -6x minus 13 plus, not plus, well, plus is fine, -35/2. Now, if you do not want to worry about the fraction, we can multiply this by 2, because that will help us here. And then we would get the 35, but this is okay, guys. Okay. Because that will help us go back to our original polynomial when we multiply that 2 out. All right, let's look at example 2 and just play around with this. So find p of -2 using the remainder theorem. So remember, this is talking about x plus 2. So we're going to find if this is a factor or not, just if it's a factor using the remainder theorem. So we just plug in, so we get 2 times -2 cubed minus 5 times -2 plus 3. And what do we get? We get negative 3. So that means the remainder is negative 3, and then we know that x plus 2 is not a factor. Let's try number B. We're going to see if, use the fact that x equals 1 is a 0. So it is a 0. Find all the real zeros. Okay, so remember x is 0 means that x minus 1 is a factor. Okay, so we are going to use, of course, synthetic because that's the easiest. So I have 2. You don't have an x squared, so don't forget that 0, negative 5, and 3. And then, of course, we're going to use the value of 1. Now, we know that this should work, so we should get no remainder here. But that's going to help us factor even more, right, by using the quadratic formula. So, 2 multiply, 2 add, multiply, add, multiply, and 0. So it worked. We did get that factor. Okay, so what does that mean? That means x minus 1 times 2x squared plus 2x minus 3 is our first step in factoring. To find the factors, so to find, here's the big thing with your directions. Make sure this isn't just factor, this is find the real zeros, okay? Well, of course, the first one is x equals 1. That came from out here. But this one, you're going to have to use the quadratic formula, and you find that x equals negative 1 plus or minus the square root of 7 all over 2. Again, if you need help doing that quadratic formula, either ask me about it or you can look it up on YouTube. There's tons of resources that you can look at. All right. Here's one more example, guys. Yeah. Okay. Let this be a function. Given that x is 1/2 is a 0 of multiplicity of 2. Find all real zeros. So multiplicity of 2 means that we can do it twice. And this helps us a lot as we factor it, because the first time we factor, we're going to get x cubed. And we don't know how to factor x cubed, so we'll have to do it again to get to an x squared to be able to find all of our zeros. So multiplicity tells you how many times it can work. Okay, so we're doing 1/2. So I'm going to do synthetic with 1/2. 4, -4, -11, 12, and 3, -3. There's nothing missing, so that's good. I also know that since it is a factor already, so it is a 0, that the remainder should be 0. Okay? I'm not going to use colors anymore because we should be able to do this now. Bring that down. 4, multiply, add. Let's see. Multiply, add, multiply, add, multiply. Oh, and it worked, right? So that's good. So right now what we have is x minus 1/2 times 4x cubed minus 2x squared minus 12x plus 6. But of course, we don't know how to factor this, so we have to do synthetic again. Get used to this, guys, because you're going to do a lot of synthetic. Make sure you're showing your work on another sheet of paper. Okay, now it said it's twice multiplicity, so guess what? I'm going to do it again. Okay, but this time I'm going to use these values because we've already used the first values. So I get 4, -2, -12, and 6. I don't need to put that 0 in. Now they should also come out to a remainder 0 because it works twice. 4, multiply, add, multiply, add, multiply, add. Awesome. Okay, so what does that mean so far? That means we have x minus 1/2 times x minus 1/2. Remember, this comes from the first part, this comes from the second, times, this is constant, x to the first, x squared, so 4x squared minus 12. Can we factor that part? Yes, we can. So here, we know our factor is x equals 1/2. And we know that if we just solve for this, add 12, divide by 4, square root it, we get x equals plus or minus the square root of 3. Okay, the other way we can see this written, guys, is x minus 1/2 squared times 4x squared minus 12. Okay, and that's just another way to write it. We're going to do a lot more with synthetics, so make sure you get some practice. So here are some connections. Suppose p is a polynomial function of degree where n is greater than or equal to 1. We have to see the following statements. The real number c is a 0 of p. Okay, that means p of c equals 0. X equals c is a solution where when we plug it in equals 0. X minus c would be a factor, and the point C0 is an x-intercept. So all of these things, zeros and x-intercepts, interchange. All right, guys, have fun practicing.